Hi there, in this tutorial I'll show you how you can use an ambient light sensor board with a Pico 2 and MicroPython. This project will get the current light level and then turn on the LED on board the Pico 2 when the light is low. This project will also work on the original Pico. Now let's start by looking at what's needed for this project. In terms of hardware, you'll need a Pico or a Pico 2 with or without Wi-Fi and Bluetooth, a USB-A or USB-C to micro B cable, a breadboard, a VEML7700 based ambient light sensor. The one I have is an Adafruit VEML7700 lux sensor, and lastly, suitable wires to connect the Pico to the light sensor board. I used 4 DuPont male-to-male cables to go from the Pico 2 to the breadboard, and a Stemma QT 4-pin to 4-pin male DuPont cable to go from the sensor to the breadboard. There are links in the description for each one I used. As for software, you'll need MicroPython installed on the Pico, Python installed on your local computer, and Visual Studio Code with the Python and Raspberry Pi Pico extensions installed. If you would prefer, you can also use Thonny instead. Now, let's get everything connected up. The cabling of the light sensor to the Pico 2 is done by using the GPIO pins for the I2C bus and 3.3 volt power and ground. Coming from the Pico 2, the 3.3 volt power, the red wire, is connected from pin 36, and ground, the black wire, is coming from pin 33. The I2C connections are from pin 1 for the SDA, that's the blue wire, and pin 2 for SCL, which is the yellow wire. I2C bus 0 was what I used for this project. As for the VEML7700 sensor, I plugged the Stemma QT cable into the right side connector and then simply matched the wires with the same colour wire from the Pico 2. Now let's build the program to make this all come together. Before you get started, make sure to download the source code from GitHub using the link in the description, as there are some custom modules in there that are required for this project. There is also a link to a blog post with all the code in there, along with step-by-step instructions if you would prefer that format instead. Oh, a quick shout out to Paloof34 on GitHub, or at least I think that's how you pronounce that name, for the VEML7700.py module that I found, which worked on the Pico. The one from Adafruit wouldn't work, as MicroPython didn't include some of the libraries that were needed. Now, to begin with, connect your Pico or Pico 2 to your computer. Next, open VS Code. Once the window opens, click on Create Pico Project. Select MicroPython from the drop-down. Give the project a name and specify a location to save it to. Then click Create. If you get this prompt, just select Yes. Once the new window is open and files appear in Explorer, delete blink.py and leave the VS Code folder and the MicroPython file alone. They are required for the Pico extension to work. Create a new folder called Modules. In that folder, create a file called __init__py. Close that file. Next, create a new folder in the Modules folder called light_sensor. In that folder, create another new file called __init__.py again, and again close that file. Next, open up the folder that has the source code in, go into Modules, then to Light Sensor, and then just drag and drop those two files, that being veml.py and veml7700.py, into the light_sensor folder. Then open veml.py. Okay, let's go over what this module does. First, there are the library and modules that need to be imported. I2C and pin are used for interacting with the I2C bus. VEML7700 is used for interacting with the light sensor. Next, there's a function called veml_setup that will initially set up the I2C bus settings. This includes the bus number, GPIO pins, and frequency to use. These all have default values which match the wiring diagram and the I2C address on the back of the sensor board. Scrolling down a little bit, what it'll first do is set up the settings for the I2C bus. It'll then initialize the bus, and then once the bus is set up, the function will then attempt to connect to the light sensor. If it is successful, the function will return a VEML object that was created back to the caller. If not, it will raise an exception and terminate the program. For now, we'll close that file. In the root of the project, copy the main.py file and open it. Let's go through what this does. First, it'll import the libraries and the custom VEML module. Then we have a main function. Inside that function, there's a variable to instantiate the light sensor. If all goes well, then it will be assigned a VEML77 object that can be used to interact with the light sensor. If not, an exception will be raised in the VEML module and terminate the program. After that, an attempt to set up the onboard LED on the Pico is made. Again, if it fails, an exception will be raised. Next, a while loop is used to continuously read the sensor every so many seconds and print out the result. Scrolling down a little bit. If the sensor reading is under 39, an attempt to turn the LED on will be made. Over 39, it will turn off. If there's an issue with the LED, an exception will be raised. Then we have a sleep to delay the next loop. The sleep of 1 second is just for demonstration purposes. A much higher number, such as 60 or more, will be more reasonable. Oh, and if the sensor can't be read for whatever reason, maybe a hardware failure, an exception again will be raised. The last part of the file is to call the main function when the program starts. Now leave that file open. Now right click on any blank space in Explorer and then select Upload Project to Pico. Once that's done, right click on any empty space in the main.py file and select Run File on Pico. We can now see the output from the sensor. If I cover over the sensor and the number goes below 39, the LED turns on. When I uncover it, the LED goes off. Now, whilst it's running, I'll disconnect the sensor from the Pico. It now gives the expected exception error, indicating it can't read the sensor. Now I've still got the sensor disconnected, so what I'm going to do now is I'm going to run the program again, and this time it should show the exception error that implies it cannot set up the sensor on the I2C bus. And this time it shows the exception error that implies it cannot set up the sensor on the I2C bus. Those errors are expected for the two scenarios. If I plug the sensor back in and run the program again, it now works as expected. Now, what this covered is pretty simple in terms of it just turning on an LED on the Pico, but it can be useful in other ways. For example, making a call to an API or a webhook to turn on or off a smart light or a smart power socket to turn a lamp on that doesn't have smart capabilities. It could also work with Home Assistant to do some other home automation functions if you wish. Ultimately, the choice is up to you, but for now, that concludes this project. If you enjoyed this video and want to see more Pico and Raspberry Pi videos like this, please drop a like, comment and subscribe. If you want some Pico project ideas, I've got a playlist here on the left of some of the previous Pico projects I've done. On the right is another video that YouTube thinks you might like. But for now, thanks for watching and I'll see you next time.